Welcome to a lesson with Dr. Powell. Let's take a look at an example of how we can compute the determinant of a 4 by 4 matrix using only determinants of 2 by 2 submatrices. Now, a little side note for those familiar with group theory. Now, when we're taking the determinant, what we're doing is we're adding up um, signed permuted diagonals or diagonal products, in order to get the determinant. Now we can partition those signed products according to the permutations that they come from. So if we're working with a 4 by 4 matrix, that would be the permutations would live in S4. Now the way we can partition these up are by cosets of a subgroup. Now normally with like cofactor expansion along a column or a row or something like that, what we've done is we've actually, we're looking at cosets of the subgroup that fixes that row or that column. Now, why can't we just expand this to multiple columns or multiple rows? Here's an example. Um, let's suppose that we have two columns here. Let's just focus on these first two columns. And the subgroup that, that keeps these first two columns here in this position could be represented by something like this, using cycle notation. So these guys can switch, those guys can switch, or you can switch those, and or you can just do nothing. And this would actually keep this guy over here. Okay, so the way we end up doing this is we pick out a submatrix along this in this column. Now, kind of what this is the submatrix that we pick would represent a coset, and that coset is the one that takes that's this submatrix and makes it a central submatrix, like puts it like so its diagonal is on the diagonal itself of the overall matrix. So, um, and so that would be, and we can actually split up the cosets of H according to different submatrices of this being selected to become a central submatrix along this diagonal. In that way, notice that we have four things here, and 4 choose 2 for submatrices that are 2 by 2 along here. Think about what that is. 4 choose 2 is actually equal to 6, which makes sense because there's 6 cosets of H. We need a total of 24 elements in S4. Okay, that was just a little side note for those familiar with group theory. Okay, now let's see some magic and how does this actually tick here as we go. So what we can do is we can subdivide the different submatrices, 6 of them, and we can do this rather simply. We think every time that we select 2 together, like right here, and or maybe like right here or right here, actually we have it's represented by an even permutation to bring that to the central diagonal, which actually is the same permutation that by rows, if we wanted to, if we're thinking columns versus rows, if we had a row, that would actually just take this guy up to the top, right? Because if we're doing row permutations, basically the central position is at the top. So it's going to be the same work to take this up to the top here. And if we're moving 2 things at a time together in sequence, it's always going to be an even permutation. So that's one thing that's nice and fast to consider as we're using this method. For instance, if I have it here, here, or here, I'll attach a positive sign, meaning that it's going to be an even permutation. Okay, so as we're going through this, we'll just keep that in mind. All right. Okay, now, so if we start here, notice, and if we just do one switch at a time, we go plus, minus, plus. It's a pretty simple sequence. Then from here, plus, minus, plus. It actually goes fairly fast. Let's see how it would go just remembering what we're going to do is we're going to take the determinant of this submatrix and multiply it to it the determinant what's kitty corner to it over here. For instance, right here, what we do is we take this determinant of this part, 1, 0, 2, 1, and multiply it to that determinant right there. Okay, so that would just simply be 1 times -4. So -4. Okay, now we go, okay, so we're going to keep down this line. So now we go to here, and notice that determinant will be 0, so we can skip that step, which would be a minus, so we go to the next one. We have a 1, 0, and a 1, 1. The determinant of that is 1 times what's kitty corner to it, happens to be a positive 1 determinant, and it's going to be a plus, so it's just +1. Okay, now we go down here and think, okay, next grouping. Okay, these two guys right here together. All right. And we think, okay, the determinant of this part is -1 times what's kitty corner to it is -2. So that would end up giving us a +2. And notice since they were together in this line, it's positive. So the next time, one switch over. So this being the top row and that being the next one, it's going to be a negative of what we get here. So we have 2 minus 1, which would be 1 times what's kitty corner to it, 2 minus 1, which is 1. So 1 times 1, but with a negative. So a -1. And then we're just left to the bottom guy, which has a determinant of 1, multiplied to this top guy, which has a determinant of -1. So we end up getting a -1. Okay, so then when we go ahead and compute this, that cancels, and we're left with -3, which you can check in another method, truly is the determinant of this matrix right here. Thanks for watching.